everybody, this is Miss Bufford, and this is building block 8 for Unit 12 over solutions. And building block 8 covers solution stoichiometry. And your learning goals for building block 8 are to be able to perform stoichiometric calculations for reactions involving solutions. All right, so there are two ways that we can solve problems that involve stoichiometric calculations when we're dealing with solutions. The first way is to utilize dimensional analysis, also known as the factor label method. This is what we've been doing so far for the last couple units that we've done stoichiometry with. We're basically setting up numbers in order to cancel out certain units and eventually end up with the unit that we want. We also, what makes this stoichiometry is the use of the mole ratio, which allows us to convert between an amount of one substance in moles to amount of another substance in moles. The second way is not using dimensional analysis, and I know some of you are probably cheering inside, but I'm going to actually show you a way to solve these problems using something called the modified dilutions equation, which is shown below. And this is basically just algebra. So let's go ahead and get started. We'll talk about dimensional analysis first, and then we'll get into this simplified way of trying to solve these stoichiometric calculations. All right. Okay, so there are lots of different questions that can be asked that require you to use solution stoichiometry, but what we're going to focus on is the volume to volume stoichiometry conversions and volume to concentration stoichiometric conversions. Okay, for volume to volume conversions using dimensional analysis. So for this type of problem, you're going to be asked to calculate the amount of one solution that's required to react with a specific volume of another solution. And I broke this down into several different steps for you, and I tried to color code the steps along the bottom so that you guys could kind of hopefully remember what to do in each step. So the first step, which I didn't show on here, is that you want to read through your problem and you want to identify your known and your unknown. And the known is going to be the substance that you have both a volume and a concentration for. And your unknown is going to be the substance that you only know the concentration of, and you're trying to figure out what volume of that you're going to need. Step 2 is that you're going to go ahead and begin your calculation with the volume of your known substance. And once you write down the volume of your known, you're going to multiply that in step 3 using the concentration. So you're going to set this concentration up so that liters will cancel out, liters of solution A. And then you'll be left in units of moles. And now that we're in moles, we can go on to step 4 and set up our mole ratio. And remember, the numbers from your mole ratio come from the coefficients in your balanced chemical equation, right? And we set that up so that moles of the substance that we started with, substance A, cancel out, so those go on the bottom of our mole ratio. And the substance that we're looking for always goes on the top of our mole ratio. And then in this case, we're looking for the volume of the unknown. So if we know how many moles of the unknown that were required, then we can use that information along with the concentration that's given in the problem for the unknown to be able to cancel out moles and be left with units of liters. And that'll tell us what volume of that solution would be required for that problem. And again, here at the end of this video, we're going to go ahead and do some examples. All right, so now we're going to be talking about converting from a volume to a concentration of another solution. So in this type of problem, you're going to be asked to calculate the concentration of one solution that's required to react with a given volume of another solution. And so again, I broke this down into steps for you guys. Step 1 is for you to identify your known and your unknown substances. So the known is going to be the substance that you have both a volume and a concentration for, and your unknown is going to be the substance that you only know the volume for in this case. Step 2, you're going to go ahead and start setting up your problem. So you want to begin with the volume of the known. So look down here, I've put liters of solution A. And then you want to multiply that in step 3 by the concentration of that solution. And you're using concentration as a conversion factor here. So you're setting it up so that liters of solution A will cancel out. And you'll be left in units of moles of A. And then now that we're in moles, we can go ahead and set up our mole ratio. And we want to set our mole ratio up so that moles of substance A cancels out. But remember, in a mole ratio, the numbers that we use, they come from that coefficient in our balanced chemical reaction or equation. And then we set that up so that the moles of our unknown are on top. And that, for this type of problem, if we're trying to calculate a concentration, the problem already gave us a volume for our unknown. So if we can figure out how many moles of unknown we have, all we have to do is divide the moles of the unknown by the volume of the unknown in liters, and that will allow us to calculate our molarity or our concentration. All right, so another way that we can solve solution stoichiometry problems is to use the modified dilutions equation. And by modified, I mean that we're including the moles from our balanced chemical equation. So as you can see, we have M1 V1 equals M2 V2, but we've added in a little lowercase n for N1 and N2 to this problem. And that's in place of our mole ratio. So that right there is going to help us be able to make that conversion between the two substances, okay? And when you use this, all you have to do is list out your variables and, list the information you have for each one, and whatever one is your unknown, you just rearrange this equation to solve for that unknown, and then you can plug all your numbers in and hopefully get the right answer. So when we do our examples for dimensional analysis, I'll also be solving all of those problems using this modified dilutions equation, just to show you side by side the two different methods. Example calculations for solution stoichiometry. This first problem is going to ask us to calculate the volume of one solution if we're given the concentration and the volume of another solution that it's reacting with. So let's go ahead and read through the problem. We're going to do stoichiometry with dimensional analysis first, and then we'll go back through and use the modified dilutions equation to solve these same problems. All right, so how much of a 0.20 molar phosphoric acid solution is needed to react with 100 milliliters of a 0.10 molar sodium hydroxide solution? So first things first, I need to identify my known and my unknown by making a list of what I have for each of these compounds. So this is asking me how much, which means it's asking me for the volume. So my volume here is my unknown. And it's telling me that the molarity of this solution is 0.20 moles per liter. And it's telling me that for sodium hydroxide, my volume is 100 milliliters, and my molarity is 0.10 moles per liter. Okay? So we can see that this right here, this is going to be my unknown, phosphoric acid, H3PO4, and the compound that is my known is going to be sodium hydroxide, because I know both the volume and the molarity for that. Step 2 says to go ahead and start my stoichiometric calculation with the volume of the known. Okay, so I want to start with what I know, and I know that I have 100 milliliters of sodium hydroxide. Okay. Whoa. All right. And I know that I'm going to eventually need to use this molarity, which is expressed in moles per liter. So if I'm going to be able to use this to cancel out volume, then the volume units need to match. So I have to convert milliliters to liters first. So I know that there are 1,000 milliliters in 1 liter. Milliliters will cancel out, and now I'm in units of liters. So now I can use that concentration. So I'm going to go ahead and set that up so now liters will cancel out. So 0.10 moles over 1 liter. So now liters will cancel out. That's moles of sodium hydroxide. Okay. And now that I'm in units of moles, I can go ahead and set up my mole ratio. So I've got moles of sodium hydroxide here. I know that I'm going to have to cancel that out, so moles of sodium hydroxide should go down here. But remember, when we're setting up our mole ratio, the number comes from our balanced chemical equation. So it's the coefficient in front of that substance. So this is 3 moles of NaOH here. And then on top is going to go the substance that I'm trying to find. So in my balanced equation, there is no coefficient in front of that, which means I just have 1 mole of H3PO4. All right, so then moles of sodium hydroxide will cancel out. Now my units are moles of phosphoric acid, but the problem is asking me to calculate a volume. And so what I'm going to do is I'm going to use the molarity from phosphoric acid to be able to cancel out moles, and it'll leave me with a volume. So I'm going to use that like a conversion factor, and I'm going to set moles on the bottom, so 0.20 moles in 1 liter. So moles will cancel out, and that'll leave me with liters of phosphoric acid. And if I plug this all into my calculator, I end up with 0.017 liters. And since that's such a small number, I need to go ahead and convert it back to milliliters, which means I'm just multiplying it by 1,000. And when I do that, I can just move the decimal place over 3 spaces, and I end up with 17 milliliters. Okay, so there's the first way using stoichiometry. And now let's go ahead and use the modified dilutions equation. So I'm going to go ahead and write that up here. I've got M1V1 over N1 equals M2V2 over N2. And I'm just going to list out these variables, look for what I don't have, and then rearrange this and solve to find my unknown. So when you're assigning the 1 and the 2 to be a compound, you want to just make sure that the molarity, the volume, and the mole amount that are all labeled with 1s all come from the same compound. It doesn't really matter which compound is which. Like, it doesn't matter if I use M1, V1, N1 to represent the values from phosphoric acid or from sodium hydroxide, as long as all those values all come from the same compound, okay? So I'm just going to go ahead and come over here, and since phosphoric acid is listed first, I'm just going to list that as my compound number 1, and this is going to be compound number 2. And now I'm just going to go ahead and list out my variables. So I have M1, V1, N1, and then M2, V2, N2. And now I'm going to go ahead and read through my problem. So for compound 1, I already have all the information listed from when I did stoichiometry here. So I'm going to pull my numbers from here. For phosphoric acid, since that's compound 1, I know that the molarity is 0.20 moles per liter. My volume is what I'm looking for. And in my balanced chemical equation, there is no coefficient in front of phosphoric acid, which means I just have 1 mole of that. So I'm going to put 1 mole here. And then for my second compound, the molarity for sodium hydroxide was 0.10 moles per liter. I had 100 milliliters of that. And my coefficient in my balanced chemical equation for sodium hydroxide is 3, so I have 3 moles here. Okay. The other cool thing about using this equation instead of the dimensional analysis is that you don't have to convert your volumes to liters. You can leave them as milliliters. Just be aware that since we're calculating a volume here, our volume is going to be given in milliliters. All right? So since we're looking for V1, I'm going to go ahead and circle that here, and we need to isolate V1 and get it by itself so that we can solve the equation for that. So the first thing I need to do is multiply both sides by N1. Right? That's going to cancel out N1 on this side. And then I need to divide both sides by M1. And that's going to cancel out M1 on this side. And so my final equation is going to be V1 equals M2 V2 N1 divided by N2 M1. All right, so let's go ahead and plug in those values and see what we get. I'm going to go ahead and squeeze it down here so I have more room. So V1 equals, and then my value for M2 is 0.10 moles per liter. V2 is 100 milliliters. N1 is 1 mole. And then down here I have N2, which is 3 moles. And M1, which is 0.20 moles per liter. All right, so let's go ahead and take a look at what's going on with the units here really quick before we finish this problem up. Molarity, I have a molarity on the top and a molarity on the bottom, so those units are going to cancel each other out. I have moles on the bottom and moles on the top, so they're going to cancel each other out, and I'm left with units of milliliters. And that makes sense since I'm calculating a volume. So if I go ahead and put all this in my calculator, then I find out that V1 equals 17 milliliters. All right, so there we go. Let's go ahead and move on to the second problem. All right, so if 36.0 milliliters of phosphoric acid react exactly with 80 milliliters of a 0.500 molar sodium hydroxide solution, what is the concentration of phosphoric acid? So again, I'm going to go ahead and start using stoichiometry to solve this, and then we're going to go ahead and use the modified dilutions equation so that you can see how we would solve this problem using that equation as well. Okay? So first things first, I'm going to go ahead and I'm going to identify my known and my unknown by making a list of what I know about each compound. So for phosphoric acid, I know that my volume is 36.0 milliliters. And my volume for sodium hydroxide is 80.0 milliliters. My molarity for sodium hydroxide is 0.500 moles per liter. And it says, what is the concentration of phosphoric acid? So here we're looking for molarity. That's my question mark. So again, phosphoric acid is my unknown in this problem, and sodium hydroxide is my known. So I'm going to go ahead. Step 2 says start with the volume of your known. So I'm going to start with 80.0 milliliters NaOH. And I'm in milliliters, and I'm using stoichiometry, so I have to convert that to liters so that I can get liters to cancel out. So I'm going to go ahead and divide that by 1,000, because I know there's 1,000 milliliters in 1 liter. Milliliters cancels out. Now I'm in liters. Now I can use that concentration to get to moles. So 0.500 moles in 1 liter. Liters will cancel out now. And now I'm left with units of moles of sodium hydroxide. And now I can set up my mole ratio. And I'm trying to get moles of sodium hydroxide to cancel out, so that needs to go on the bottom of my mole ratio. And remember that number comes from my coefficient in the balanced chemical reaction, so 3 moles of sodium hydroxide. And I'm trying to figure out how many moles of phosphoric acid. So I'm going to write 1 mole H3PO4. And with this particular problem, since it's asking me to calculate a concentration, I just really need, with this step, to figure out how many moles of phosphoric acid were required to react. Because if it tells me how much volume I have, then if I calculate how many moles, then I can just divide the moles by the volume, and that'll tell me what the molarity of that solution was. So if I stop here and I hit enter on my calculator, then this tells me that I have 0.0133 moles of phosphoric acid, H3PO4, okay? And if the problem told me that the volume that was required was 36 milliliters, that means I have 0.0133 moles of H3PO4 divided by, and I have to convert 36 milliliters to liters in order to get a molarity, because molarity is always in moles per liter. I would just divide 36 by 1,000 or move that decimal place over to the left 3 spaces. So 0.036 liters. And that would give me a final answer of 0.37 moles per liter. So there's my concentration right there. All right, so now let's go ahead and use the modified dilutions equation to go ahead and solve the same problem and see what we get. So again, here's my equation. M1 V1 over N1 equals M2 V2 over N2 . Right. All right, M1. I'm going to go ahead again and just label my first compound as number 1 and my second compound as number 2. So all of my M1, V1, N1 values have to come from phosphoric acid, and all of the values with a subscript of 2 have to come from sodium hydroxide. So my molarity for phosphoric acid, I don't know that. That's what it's asking me to calculate. So I'm going to put my question mark right there. It's telling me that I have 36.0 milliliters for my volume. And in my balanced chemical equation, there is no coefficient, so that means I just have 1 mole of that substance in my equation. And then for sodium hydroxide, my molarity is 0.500 moles per liter. My volume is 80 milliliters, 80.0 milliliters. And my mole amount for my balanced reaction is 3 moles. Okay, so I know that I'm solving for M1, so I'm going to have to go ahead and isolate M1 in this equation. So I need to rearrange. In order to do that, I have to multiply both sides by N1. And that gets rid of N1 on that side. And then I have to divide both sides by V1. And that gets rid of V1 on that side. And so then my final equation would be M1 equals M2 V2 N1 over N2 V1. All right, so let's go ahead and plug in our variables. I'm going to squeeze that down here. M1 equals, all right, so N2 is 0.500 moles per liter. V2 is 80.0 milliliters. N1 is 1 mole. And that's going to be divided by N2, which is 3 moles, and V1, which is 36.0 milliliters. All right, so if I plug all that in my calculator, I end up with 0.37 moles per liter, which matches what we got when we did stoichiometry. So there we go. I hope this video was helpful. If you guys have any questions, go ahead and write them down, or feel free to send me an email. You can message me on It's Learning during my office hours between 10 and 11 a.m. And I hope this was helpful.